and the General Manager of the CIM-UPC. Ladies and gentlemen, please welcome to the stage Arnau Valls. Yes, it's okay to clap. And Felip Fenollosa. You want to come up? Okay, he'll bring you up. He'll bring you up, that's fine.
Hello. Well, thank you for the organization and for making this possible with all the situation we had here in Catalonia these days. I'm Arnau Valls, and I'm going to talk about what we do in the hospital, Sant Joan de Déu, with 3D printing. Our hospital, just a little numbers, is a hospital that is here in Esplugues de Llobregat. We have 200,000 outpatients a year and of 14,000 surgeries a year. What we do with 3D printing? Basically, we apply 3D printing for surgery planning, and we have some projects in prototyping of medical devices and also in prosthetics and orthesis. We are working more and researching on that last area. How we get that? What was our journey? We started in 2013 with our Dr. Lucas Crowell, with his oncological surgeon, that had a big problem. He had to face a major complicated surgery with a tumor of a kid of 11 years old that had the tumor around main vessels. What happened? They tried to intervene, but when they entered to the surgery, just with the images they got from radiology, they couldn't see some of the vessels that were inside, and when they opened, they couldn't intervene. They preferred to close and go back and think again how to intervene. In that moment, it appeared Felip Fenollosa talking with Lucas Crowell and saying that there's a possibility of creating a 3D model in which they could see the anatomy of the patient, plan, and even try the surgery before going to the real surgery in a 3D model. No? So they did that, and the surgery was great. It went perfect. From that moment till now, there's been lots of other surgeons that come in and try to do some cases with 3D printing, and now we have 6 different services trying and doing 3D printing in their normal basis or doing research, mainly in maxillofacial surgery, oncology, and traumatology. What we have, more than 50 surgeries a year, half of which are from maxillofacial surgery or orthodontic surgeries, mainly. Also 1 medical product commercialized and 2 in development. But this process, the 3D printing process, made a huge change on the process of preparing a surgery. Before, we had the MRI and the CT scan. We got the DICOM. With that, we created an image in 2D in which the surgeons studied and planned how to intervene, and then with 1 study, they get into the surgery and did the surgery. Now, with the 3D printing, we have 2 more steps. We have the MRI and the CT scan, but then we have to create the 3D design. With that design, you can print out the first models, have a second study, all that with the surgeon, the radiologist, and the engineer. Then create, if you need any other type of piece that can help the surgery, for example, cutting guides that guide how to enter to the body of the patient, or positioning guides to place the pieces they have to place if there's, for example, a replacement piece or another kind of material. And after that, they enter into surgery. So you can understand that with this change, we had to do something. And with that volume, we had to do something. Now we are thinking and creating a service in-house to put all these things in order to create the process and try to control cost and give a good service to our physicians. What are the benefits for that? What we've learned these years? We've learned that we improve security, time of anesthesia and ischemia, and then that you have simulation and training as if you were an automation professional, that you have to take a plane and you have to simulate several hours before taking the plane. So it's the same in surgery. Now you can train there and then go to the surgery with that plan. Second, efficiency. You can reduce the time inside the surgery with all the professionals and reduce the cost of the intervention. Of course, there's a plus in cost before the intervention. And finally, you improve the clinical outcomes. So let me ask you something. Imagine you are dads or moms of a daughter that have cancer and have to go through a critical and complicated intervention. What would you choose? Would you prefer the classical intervention with one image from radiology, or would you prefer an intervention in which they can plan and do all this process several times before entering to the real surgery? I think the answer is clear. What's the big challenge then for having that, the great cost it have? Nowadays, you can have paid by the public service a new knee or a new piece that have to be inside your body, which is designed and created for everybody. But it's not covered a piece that it's designed with anatomy and for the anatomy of that patient. How can it be possible? Well, that process have to be prepared, designed, worked out, so that can it go to the surgery and be covered by the healthcare sector. But I think that's the big challenge, and that's the next step we should face. We should have a healthcare system that can pay for these kind of interventions as soon as possible. And it's not only me and our experience that says that. That's a bulletin from the College of Surgeons of America, which in 2016 said and proved that there's lots of benefits from using 3D printing in a normal use of surgery. So I think it will come. Thank you. I led you with Felip Fenollosa, which we are working together with Hospital Sant Joan de Déu to make this service possible, to do research and improve the 3D printing on surgery. Thank you.
Okay. Okay. Be welcome. Thanks a lot to be here. I'm Felip Fenollosa. I'm the general manager of CIM-UPC. That is a technological center within the Polytechnical University of Catalonia. Okay, so I am introducing you, continuing what Arnau has talked about how we are trying to make possible the introduction of a massive use of rapid prototyping, of 3D printing, of additive manufacturing, whatever you want to call, you name it about, okay, into health, into hospitals. First of all, we are a research training, an advanced technological institute, as I said, into the university. But we are a foundation with private aim, with non-lucrative but, etc. In fact, as I say here, we are self-financed. We live with what we do. It seems normal. Okay, we are open from more than 25, from 1989, okay? And our aim into the university is whatever that refers about fabrication, of manufacturing, digital manufacturing. CIM means computer integrated manufacturing. I'm sure that if today we need a new name, our name would be Industry 4.0. But our name, our brand is CIM. Okay, and finally, we have a leading role in additive manufacturing. And we do that just making real things. Here in the picture, you can see a photo of our floor shop, where we develop real cases. Another part of our activities is developing open source technology, as long as we are owned by a public university. And, well, what we are doing, for instance, is a real case-based training, and that is the project BCN 3D Technologies. This project within the CIM develops 3D printers, open source 3D printers, as the one that you can see on the right, the Sigma BCN 3D printer, desktop printer. that printers with 2 independent extruders, we develop and manufacture in the UPC campus in Castelldefels. And well, by now it's the 3rd, 4th brand of 3D desktop 3D printers in the world. We produce more than 50 printers per week, and 90% are exported overseas, 50% to USA, to the States. Okay, another thing to put into put reference about CIM Foundation. Just this September 19, we opened the new Rico Additive Manufacturing Center, and well, with a brand new machine with bed powder fusion and SLS. We are just opening a new pole, a traction pole about rapid manufacturing, rapid prototyping here in Barcelona. If you want more information about this point, you can find it over there in the Rico stand. They are proposing you to visit CIM just these days. Okay, what have we been doing over last years about health and 3D printing? Well, Arnau has told you things about that. More of the slides that Arnau has shown you is what I was going to tell. So I'm simplifying. Here you can see Dr. Lucas and Lucia, the radiologist, examining prototypes made in CIM-UPC and trying to decide what to do. This is the surgery room. This is a heart. As you can see, this is a heart without the tumor. No, this is with the tumor, but we print prototypes with the tumor and without the tumor in order to see perfectly the vessels affected by the infiltration of the tumor, for example. The process has been explained by Arnau. I'm not going to repeat it, but it's that: scanning, segmentation, cut file, approval, and then production, training, planning, surgery, and evaluation, comparing what was the tumor with the real prototype. And what we are doing with our machines, with our desktop machines, is things like also Arnau has told you about orthosis, prosthetics, okay, things that would improve the life of young people. Okay, like this. This is a real case. You would find it in the net, okay, about children without hands. That with a 3D printer, this is the hand printed in a printer that doesn't cost more than 3,000 euros, okay, and in only one construction you get a personalized hand. That's very interesting stuff. And if you want to know more information about this, you can search for Enable the Future and things like this. Okay, we do all this with a lot of machinery. Okay, we have own machinery. There are machinery of partners, technological partners of other parts, and I have no problem talk about trademarks. We work we work with 3D systems. We work with strategies. We work with our self printers. There's no problem. Every rapid prototype machine, I think it may be useful for this purpose. Okay, I was here 1 year ago talking about things like this. What did we say just 1 year ago in this fair? Well, we talked about that we wanted to develop real multi-material possibilities with open source solutions, and we are still working about that. Okay, multi-material in an open source environment, it's really difficult. Big industries, big players are improving, and that's perfect, and we are taking advantage of that. But we have done things. We have done several things. So by now, we have done a lot of things. If these 7 points, I think that it's to sum up what we have done in more or less 1 year and a half. First of all, let's see the images. First of all, for example, we are talking about hertz, how to simulate flux, the flow of blood into heart, distinguishing what is the venous blood and what is the arterial blood. So in order to repair, these prototypes are made in order to repair hearts. Another very interesting things, you are going to see those prototypes on the spot there. It's about soft tissues, okay? And these soft tissues, here there are vessels and there are tumor nodules inside. They are soft, and this, for example, is more transparent, but a little rigid, and this is very soft, so the surgeon, it's silicone, okay? And the surgeon is going to planning the surgery here. I'm not going to detail how this has been done with rapid prototyping. This is silicone, and here we have used 3D printing to finally obtain this. Well, it's not secret, but it's hard work that we are still improving. Here we are just testing new materials, new monomaterial 3D printing. As you can see here, these are bones, but bones with different materials, okay? Here, what you are seeing is transparent and rigid materials, because it's a matter of fact that when we do services or helping Hospital Sant Joan de Déu, we are not doing, for a case, we are not doing one prototype, we are doing several. We test, and every prototype that we deliver to the surgeon gives him new information, new useful information. So it's very common that for a case we make more than one prototype. I can't avoid talking you about the hard work with CAD files. There is no automatic path between the scanning and the STL file. Okay, I suppose that everyone knows what is a STL file, the file that I need for a 3D printer. And here there are a lot of hours. Not only a lot of hours on a desktop, on a computer desktop, there are hours, as Arnau told before, talking with the surgeons and deciding what is useful, what it must be more over-represented, and what not. And we are working here, for example, you can see the new CIM-UPC printer. It's a printer with a height surface capacity. That it's not only that here we can do a very huge prototype with an open source machine. It's the fact that here we have improved, for example, how to treat the filament, okay? And this is going to allow us, for example, soft material, soft filament, soluble filament to process it better. And with the aim of surgery prototypes that are multi-material, that are very impossible geometry, well, improve their quality. So this machine was just show up at Birmingham just past week. Okay, so we are foreseeing things like this. As long as you have seen today that Arnau is not just telling you one case, one another case, he's talking about 50 cases that he's structuring a whole of how to say it, the cases and demands of the surgeons. This is going on. So here, this is our farm in Castelldefels. This farm now is applied to produce printer parts and test printers before being sent overseas. But you can imagine here a floor shop, a farm, in order that the everyday prototypes of the hospital are being made, as long as radiology are made just instantaneously and send it to the doctor. And finally, this is my last slide. Okay, we aim to do research project. We are waiting here in Catalonia for a community project where a lot of partners that are here. I think that here we have IBEC that here we have Avinent, I don't know, a lot of partners that we are coordinating. And well, this is a lot of things that we have the head full of ideas, full of good ideas, and we think that we are just Joan, that Catalan makes things. Thank you a lot.
Thank you very much.